So we're doing part one of these solving systems using elimination today. So we're just going to be adding and subtracting. When we add these two systems or two equations in order to solve for one of the variables, it's because one of the variables have opposite coefficients. So the number in front of the variables are opposites. So we can just add the rest of the terms together or combine like terms in order to solve for the variable that does not cancel out. If you look at number one, you have negative 4x minus 2y is equal to negative 12, as well as 4x plus 8y is equal to negative 24. Because your x values have opposite coefficients, the negative 4 and the positive 4, you can add these two equations, and those x values are going to cancel each other out. From there, you would just add the negative 2y plus the 8y, which is 6y, and the negative 12 plus the negative 24, which is negative 36. From here, you can just divide each side by the 6 to get y by itself, and you have that y is equal to negative 6. Once you get one of the variables, you're going to choose either the top or the bottom of the original equations and solve for the variable that's not solved for. So for example, if I just choose the top equation, that's going to give us negative 4x minus 2 times y. We found y to be negative 6, so it's going to be negative 2 times negative 6 is equal to negative 12. We multiply the negative 2 times the negative 6, which is positive 12, so that gives us negative 4x plus 12 is equal to negative 12. From here, we're going to move the 12 over by subtracting it from each side. So this is negative 4x is equal to negative 24. We divide each side by the negative 4, and we have that x is positive 6.
Does it matter which one you put the y into?
It could be either the top or the bottom of the original equations. It just has to be one of the original. So if your x is 6 and your y is negative 6, your solution to this one is positive 6, comma negative 6. For number 2, you have 4x plus 8y is equal to 20, and negative 4x plus 2y is equal to negative 30. Which of these two variables, your x or your y, have opposite coefficients? The x's. So you can just add these, and your x's will cancel. The 8y plus 2y is 10y, and 20 minus 30 is negative 10. To get y by itself, we'll divide each side by the 10, and y is equal to negative 1. From here, which equation do you want to use to plug that negative 1 in for y? Top or the bottom? Top one. So that's going to give us 4x plus 8 times negative 1 is equal to 20. The 8 times negative 1 is negative 8, so that's 4x minus 8 is equal to 20. We add the 8 to both sides. We get 4x is equal to 28. Then we divide each side by the 4 to get x by itself, and x is 7. If x is 7, y is negative 1. The ordered pair, that's your solution, is 7, negative 1. For number 3, we have x minus y is equal to 11, and 2x plus y is equal to 19. Which of your two variables have opposite coefficients? Your y's. So we can just add these, and your y's are going to cancel. Your x plus 2x is 3x, and 11 plus 19 is 30. So 3x is equal to 30. We're going to divide each side by the 3 to get x by itself, and that gives us that x is 10. If we plug the 10 into one of the original equations, which one would you like to use, top or bottom? I would use the bottom one, just because your y is positive there, and then you're not going to have to move the y over or divide each side by a negative 1. So if you use the bottom, you have 2 times x, which is 10, plus y is equal to 19. The 2 times 10 is 20, plus y is equal to 19. You subtract the 20 from each side, and you get that y is equal to negative 1. So if your x is 10, your y is negative 1. That gives us 10, negative 1 for our solution. For number 4, you have negative 6x plus 5y is equal to 1, as well as 6x plus 4y is equal to negative 10. Do you have variables that have opposite coefficients in front of them?
Yes.
What?
6x and 6x.
Okay, so if we just add these two equations, the 6x's are going to cancel. The 5y plus 4y is, and 1 minus 10 is negative 9. So if we divide each side by the 9, y is negative 1. Which equation do you want to use, top or bottom? Okay, so 6 times x plus 4 times negative 1 is equal to negative 10. The 4 times negative 1 is, to move the negative 4 over, so that gives us 6x is equal to negative 6. We'll divide. And x is negative 1. So if x is negative 1, y is negative 1, our solution is negative 1, negative 1. For number 5, you have negative 2x minus 9y is equal to negative 25, as well as negative 4x minus 9y is equal to negative 23. For this one, you do not have coefficients of either the x or the y that are opposites of one another. However, your y's do have the same coefficient, which is the negative 9. You have the negative 9y in the top equation, you have the negative 9y in the bottom equation. So in order to cancel your y's out, you'll have to subtract. Remember, subtracting is the same thing as adding the opposite. So if you were to subtract these, it would be the same thing as saying add the opposite of everything. If you distributed that negative into the parentheses, that means you would have everything turning into positive.
So you wouldn't multiply negative across?
You can.
You can do that, right?
It's the same exact thing as just adding the opposites.
Okay.
Okay. For this would leave you with negative 2x minus 9y is equal to negative 25, as well as positive 4x plus 9y is equal to positive 23. If we then added these, the negative 2x plus 4x is 2x.
Yeah.
The negative 9y plus 9y cancels out. And the negative 25 plus 23 is negative 2. From here, we can just divide each side by the 2, and you get that x is equal to negative 1. To plug this in, it has to be from one of the originals. So if you decided to use that bottom equation, you would have to use the negative 4x minus 9y is equal to negative 23. If it was me, I would just use the top one. So that would give us negative 2 times negative 1 minus 9y is equal to negative 25. The negative 2 times the negative 1 is positive 2 minus 9y is equal to negative 25. We can subtract the 2 from each side to give ourselves negative 9y is equal to negative 27. We divide each side by the negative 9, and y is positive 3. If your x is negative 1, your y is positive 3. That gives us negative 1, 3 for our solution. For number 6, we have 8x plus y is equal to negative 16, as well as negative 3x plus y is equal to negative 5. Do either of these variables have coefficients that are the same or opposites? Your y's have the same, right? Okay. So if we were to subtract the bottom equation from the top equation, we can distribute the negative in, which is the same thing as adding the opposite. So this is going to give us 8x plus y is equal to negative 16, as well as positive 3x minus y is equal to positive 5. From here, if we were to add these, the 8x plus 3x is 11x. Your y minus y cancels, and negative 16 plus 5 is negative 11. So divide each side by the 11 to get x by itself, and you have that x is equal to -1. Which do you want to use to find for y? The top equation or the bottom equation? Top one. So this is going to give us 8 times x, which is -1, plus y is equal to -16. The 8 times -1 is -8, plus y is equal to -16. We move the 8 over and add it to both sides. So y is equal to -8. If your x is -1, your y is -8, what's your solution? -1, -8. For number 7, you have -6x plus 6y is equal to 6, as well as -6x plus 3y is equal to -12. Your x values here have the same coefficient. They're both the -6, so you're going to have to subtract these. If we subtract, again, we have to add the opposite. So this is going to give us -6x plus 6y is equal to 6, as well as positive 6x minus 3y is equal to positive 12. If we add these two, those 6x's cancel. The 6y minus 3y is 3y, and 6 plus 12 is 18. We divide each side by the 3, and we get that y is 6. If we plug this 6 in for y for one of the original equations, which would you like to use, the top or the bottom? Top. So it doesn't matter. It's up to you. Which one? Pick. You want to use the top one? I think the top one would be easier because you're working with like a smaller number on the right side that your equation's equal to. So you have -6x plus 6 times y, which is 6, is equal to 6. The 6 times 6 is 36, so that's -6x plus 36 is equal to 6. Move the 36 over, subtract it from each side. So it leaves you with -6x is equal to -30. Divide each side by the -6, and x is positive 5. So if x is 5, y is 6, that means 5, 6 is your solution. For number 8, you have 7x plus 2y is equal to 24, and 8x plus 2y is equal to 30. For this one, we're going to have to subtract it as well because your y's have both a positive 2 in front of them. So if we subtract the bottom from the top, we're going to have 7x plus 2y is equal to 24. We distribute the negative in, so that's a negative times 8x is -8x. The negative times 2y is -2y. And the negative times 30 is -30. From here, we're going to add these two. The 7x minus 8x is -x. The 2y's cancel. And 24 minus 30 is -6. If we then divide each side by the -1 to get x by itself, we get that x is positive 6. To find for y, which one do you want to use, the top or the bottom? Top. So that's 7 times x, which is 6, plus 2y is equal to 24. The 7 times 6 gives us, so 42 plus 2y is equal to 24. We move the 42 over by subtracting it from each side. We're going to have 2y is equal to a negative, because 42 is bigger than 24, so we keep the sign in front of it, which is negative, and then we subtract. 2 minus 4, you got to turn that 2 into a 12. Then the 4 next to it becomes a 3. So 12 minus 4 is 8. 3 minus 2 is 1. So we have -2y is equal to -18. Divide each side by the 2 here, and you get that y is equal to -9. So if your x is 6, your y is -9. 6, -9 is your ordered pair. That is your answer. Right, so with these questions, you're going to have to multiply either one or both equations in order to cancel out one of the variables. Sometimes with these, you're just going to multiply by a positive number. Sometimes it'll be a negative number. It depends on if the signs of the variable you want to get rid of are opposites or the same. If you look at number 9, you're given 5x plus y is equal to 9, and 10x minus 7y is equal to negative 18. When I do these, I look at my variable terms that are opposites. For this one, my y values are opposites of one another, except my y on top is just y, the one on the bottom is a negative 7y. So I have to make the one on top to be the opposite of negative 7. The opposite of negative 7 is positive 7. So I can multiply the top equation by positive 7 in order to make that y a positive 7y. The 7 gets multiplied by every single term within that equation. So the 7 times 5x is 35x. The 7 times y is positive 7y. And the 7 times 9 is 63. That bottom equation is going to just be rewritten right underneath this. So the 10x minus 7y is equal to negative 18. From here, I can add both of my equations. The 35x plus 10x gives us 45x. The 7y minus 7y cancels out. And 63 minus 18 is 45. From here, just divide each side by the 45, and you get that x is 1. Now, just like the ones that we did with adding and subtracting, you can plug that x in for one of the original equations and solve for y. If you do, let's say we use the top one. We're going to have 5 times x, which is 1, plus y is equal to 9. The 5 times 1 is 5, plus y is equal to 9. We move the 5 over by subtracting it from each side, and we get that y is equal to 4. If your x is 1, your y is 4. That gives you 1, 4 for your solution. For number 10, you're given negative 4x plus 9 is equal to 9, and x minus 3y is equal to negative 6. You can either do this one of two ways. You can either multiply the bottom equation by 4 to cancel out your x's, or you can multiply the bottom equation by 3 to cancel out your y's. 3 is a smaller number than 4, so I would prefer to use the 3 instead of the 4. So if I take that bottom equation and I multiply everything by 3, the top equation doesn't change, so I'm just going to rewrite it. Negative 4x plus 9y is equal to 9. The bottom equation I'm going to distribute in that 3, so that's 3 times x is 3x. Then 3 times negative 3y is negative 9y. And 3 times negative 6 is negative 18. From here, my y's are opposites of one another, so I can just add these and those y's will cancel. So negative 4x plus 3x is negative x, and 9 minus 18 is negative 9. So we can divide each side by the negative 1, and we get that x is negative 9. Take the negative 9, plug it into one of the original equations. Which one do you want to use, the top or bottom?
Top.
Top. So that's going to give you negative 4 times x, which is negative 9, plus 9y is equal to 9. Oh yeah, this is positive. Thank you. So this is positive. This is positive. And then this is going to be positive also. Thank you. Okay, so the negative 4 times 9 is negative 36, plus 9y is equal to 9. We move the 36 over, we add it to both sides. So we get 9y is equal to 45. Divide each side by the 9, and you get that y is 5. So the ordered pair, that's your solution, is 9, 5. If we look at number 11, we have negative 3x plus 7y is equal to negative 16, as well as negative 9x plus 5y is equal to positive 16. You got to look at these two variables. Your x values have a negative 3 and a negative 9 in front of them. What's your least common multiple between negative 3 and 9? Multiple. It'd be 9. Your least common multiple between the 7 and the 5 in front of your y's is 35. I'd rather work with a 9 than a 35. So my 9 is smaller. I'm going to find my least common multiple between my x's and multiply that top equation in order to turn it into the opposite of negative 9. So instead of it being the negative 3, it would turn into a positive 9. So negative 3 times negative 3 is positive 9. I multiply the entire equation by negative 3. So this is going to give us the negative 3 times negative 3x, which is 9x. The negative 3 times 7y is negative 21y. And negative 3 times negative 16 is going to become a positive. 3 times 6 is 18, carry the 1. 3 times 1 plus 1 is 4, so that's 48. Other than that, that negative 9x plus 5y is equal to 16 is going to go right underneath, and we're going to add. So the 9x minus 9x cancels. The negative 21y plus 5y is?
What?
The negative 21y plus 5y. 16. And then 48 plus 16. The 8 plus 6 is? 14. 4 plus 1 plus 1? 64. So negative 16y is equal to 64. Divide each side by the negative 16. And y is equal to? Negative 4. If y is equal to negative 4, plug it into one of the original equations and solve for x. Which one of the original equations do you want to use, top or bottom? Okay, so that's going to be negative 3x plus 7 times y, which is negative 4, is equal to negative 16. The 7 times negative 4 is negative 28, so that's negative 3x minus 28 is equal to negative 16. How are you going to move that 28 over? Add it. The 28 minus 16 gives us? 12. So if we divide each side by that negative 3, x is?
Negative 4.
So our solution to this one is?
Negative 4, negative 4.
Good. For number 12, we have negative 7x plus y is equal to negative 19, and negative 2x plus 3y is equal to negative 19. Easily, you can take your y's and multiply the top equation by negative 3 in order to cancel out those y's. So if we take that top equation, distribute in a negative 3, it's going to give us a negative 3y, which is opposite of that positive 3y that would be underneath it. So the negative 3 times negative 7x is 21x. The negative 3 times y is negative 3y. The negative 3 times negative 19 is going to give us a positive. 3 times 9 is 27. The 3 times 1 plus 2 is 5, so that's 57. The negative 2x plus 3y is equal to negative 19, goes right underneath that, and we add the 2. The 21x minus 2x gives us? 19x. The negative 3y plus 3y? Cancels. The 57 minus 19 is 38. From here, divide each side by the 19 to get x by itself, and you get that x is equal to 2. Which equation would you like to plug that 2 in order to solve for y? So negative 7 times 2 plus y is equal to negative 19. The negative 7 times 2? Negative 14 plus y is equal to negative 19. What do you do to get y by itself? Add the 14 to both sides. The negative 19 plus 14 gives us a y that is equal to negative 5. So our solution to this one is 2, negative 5. For the next one that we have is 19. You have negative 4x minus 2y is equal to 14, and negative 10x plus 7y is equal to negative 25. This one, you're going to have to multiply both equations by something in order to get rid of either your x's or your y's. The 4 and the 10, what's your least common multiple? 20. The 2 and the 7, what's your least common multiple?
14.
Would you rather work with a 20 or a 14? 14. Okay, so your y values have opposite signs, which is one good thing. You don't have to worry about multiplying a negative by anything. In order to make the negative 2 of negative 14, what would we multiply the top equation by? 7. In order to make the 7y a 14y, what would we multiply the bottom equation by? 2. So we're just multiplying both of these equations by these numbers. So distribute in that 7 onto that top equation. 7 times negative 4x is negative 28x. The 7 times negative 2y is negative 14y. And the 7 times 14, 7 times 4 is 28. 7 times 1 plus 2 is 9, so it's 98. The 2 distributed into that bottom equation. 2 times negative 10x is negative 20x. 2 times 7y is positive 14y. And 2 times negative 25 is negative 50. If we add these, the negative 28x minus 20x is what? Negative 48x. The negative 14y plus 14y cancels. And 98 minus 50 gives us positive 48. If we divide each side by that negative 48 to get x by itself, x is equal to negative 1. Which would you like to plug this negative 1 in for, the top or the bottom equation? So that's going to give us negative 4 times x, which is negative 1, minus 2y is equal to 14. The negative 4 times negative 1, positive 4. To get that 4 moved over, we subtract. So we just are working with negative 2y is equal to 10. From here, get y by itself, divide each side by that negative 2, and you have that y is equal to 10 divided by negative 2, which is negative 5. So if x is negative 1, y is negative 5, it's negative 1, negative 5 for your solution. For number 20, you have 3x minus 2y is equal to 2, and 5x minus 5y is equal to 10. For both your x and your y here, they have the same signs. So when you do multiply, whatever you're going to multiply both equations by, one of them is going to have to be a negative, so that way you can change the sign on one of the terms. Between the 3 and the 5, what's your least common multiple?
15.
Between the 2 and the 5, what's your least common multiple? Would you rather work with the 15 or the 10?
10.
Okay. So 2 times, or negative 2 times what is going to give you 10?
5 and negative
5. The bottom one, you have 5y times what is going to give you a 10y?
2.
2. Which of these do you want to be negatives?
2.
Okay. So distribute in that 5. 5 times 3x, 15x. 5 times negative 2y, negative 10y. And 5 times 2 is 10. The negative 2 times 5x is negative 10x. The negative 2 times 5y is positive 10y. And the negative 2 times 10 is negative 20. If we add these, the 5x minus 10x, 15x minus 10x is 5x. The negative 10y plus 10y cancels out, and 10 minus 20 is negative 10. If we divide each side by the 5, we get that x is negative 2. Which equation would you like to use to find for y?
Top.
Top. So that's going to give us 3 times x, so 3 times negative 2, minus 2y is equal to 2. The 3 times negative 2 is negative 6, minus 2y is equal to 2. We move that 6 over by adding it to both sides. We get negative 2y is equal to 8. And we divide each side by the negative 2. And you have that y is equal to negative 4. If your x is negative 2, your y is negative 4, your solution is negative 2, negative 4. For number 21, you have 5x plus 4y is equal to negative 14, and 3x plus 6y is equal to 6. What's your least common multiple between the 5 and the 3?
15.
What's your least common multiple between the 4 and the 6?
12.
12. 15 or 12, which one do you want to work with? 12. to multiply the top by bottom equation. What do you want to multiply? Which one of these do you want to be negative? Okay. So 3 times 5x is 15x. 3 times 4y is 12y. 3 times negative 14. The 3 times 4 is 12. Carry the 1. 3 times 1 plus 1 is 4. Make it negative. From here, the negative 2 times 3x, negative 6x. Negative 2 times 6y is negative 12y. And negative 2 times 6 is negative 12. So if you are to add these, the 15x minus 6x is 9x. The 12y's cancel. Negative 42 minus 12 is
16.
maybe negative 54. Divide each side by the 9. What does x equal? Negative 6. Which do you want to substitute that negative 6 in for x in order to solve for y? Okay. So 5 times negative 6 plus 4y is equal to negative 14. 5 times negative 6 is? So negative 30 plus 4y is equal to negative 14. You add that 30 over. You're left with 4y is equal to 16. Then divide each side by the 4. So y is equal to 4. What's your solution if x is negative 6 and y is 4? Negative 6 comma 4. Good. For 22, you have 2x plus 8y is equal to 6, and negative 5x minus 20y is equal to negative 15. Which of these do you want to get rid of, your x's or your y's? For 22, you want to get rid of your x? You want your x's? What are you going to multiply the top equation by? What about the bottom one? So this is going to give us 10x plus 40y is equal to 30, as well as negative 10x minus 40y is equal to negative 30. If you add these, the negative 10x plus 10x is what?
Cancels out.
The 40y minus 40y. So that's 0, right? The 30 minus 30 cancels out, so that's 0. This tells you that 0 is equal to 0. What kind of statement is this? It's a true statement. So our answer is infinitely many solutions. For 23, you have negative 14 is equal to negative 20y minus 7x, as well as 10y plus 4 is equal to 2x. If I were you, I would move the 10y over on this one, on that bottom equation. So that way you have negative 14 is equal to negative 20y minus 7x, as well as 4 is equal to negative 10y plus 2x. From here, what do you want to multiply by in order to cancel out one of your variables? First off, do you need to multiply both equations by something?
Yeah.
You do?
No.
I wouldn't.
Well, my comment.
I would multiply the bottom one by 2,
Oh, yeah.
so that way you can cancel out your y values. Actually, it would be a negative 2.
You would divide the top, right?
No, you wouldn't do anything to the top. The top would stay. So the top would stay. The negative 14 is equal to negative 20y
What about the
minus
y?
7x. What about it?
Negative 21 and 10y.
You're going to multiply the bottom equation by negative 2 in order to make that negative 10y a positive 20y. So your y's are going to cancel.
Okay.
So if you distribute that negative 2 and the negative 2 times 4 is negative 8. The negative 2 times negative 10y is positive 20y. And negative 2 times 2x is negative 4x. Now, from here, you can add these. The negative 14 minus 8 gives us negative 22 is equal to, your y's cancel, negative 7x minus 4x, negative 11x. So divide each side by that negative 11, and you get that x is equal to 2. Which equation would you like to use in order to solve for y? Okay, so 10y plus 4 is equal to 2 times x, which is 2. 2 times 2 is? So 10y plus 4 is equal to 4. To move the 4 over on the same side as a 10y, you're going to subtract it from each side. So you have 10y is equal to 0. Divide each side by the 10, and y is 0.
So you can rewrite the equation?
Uh-huh. You have to sometimes. If you look at the next one, your next one is like even worse than this one is. For the reason why I'm saying it's worse is because I'm going to do it a different way. So depending on the way that you look at these, a lot of the time when you're given these, you're given them in the form of ax plus by is equal to c. Sometimes when you're given them these equations, they're not in the form of that. You don't necessarily have to put them in that form. If you see the bottom equation in number 24, you have negative 3 minus 7y is equal to 10x. You can leave it in that form. There's nothing wrong with that. One of your values, your x or your y's, are going to cancel. So if you, let's say, took the top equation there and moved the 2x over by subtracting it from both sides, you would have 3 minus y is equal to negative 2x, as well as negative 3 minus 7y is equal to 10x. The only thing that you got to be careful with these is if your constant cancels out. If your constant cancels out, you didn't cancel out one of the variables, so you're not solving for one of the variables. So you have to make sure that when you're doing this, you're canceling out at least the x's or at least the y's. You can't cancel out the constant. So if I look at this, I have opposites on my x values, so I can multiply that top equation by 5, and that will get my x values to cancel out. So this is going to give us 15 minus 5y is equal to negative 10x, as well as negative 3 minus 7y is equal to positive 10x. From here, because my x values are opposites, I can just add these. They're going to cancel out to give me 0 on that side. The 15 minus 3 is 12, and the negative 5y minus 12y, or sorry, minus 7y is negative 12y. Your equation here is equal to 0. You need one of the terms to be moved over. If I want to work with a positive y, I'm going to move the 12y over by adding it to both sides. So I'm just working with 12y is equal to 12. From here, just divide each side by the 12, and you have that y is 1. Now that you have for one of the variables, solve for the other. Which equation do you want to use, the top or the bottom? Top one. So if we use the top one, it gives us 3 plus 2x minus y, which is 1, is equal to 0. If it was me, I wouldn't have used this one just because your equation is equal to 0. That's the only reason why. It's not wrong. You're going to get the same answer, but I would have used the bottom one just because I would think it was a little bit easier because my x value is already on its own side. So like I said, it's not wrong. You're going to get the same thing. But like I said, it's my preference. I wouldn't have used the top one. That's all. So the 3 and the negative 1 are like terms. Combine them to get 2x plus 2 is equal to 0. Then move that 2 over. Subtract it from each side to get 2x is equal to negative 2. And then just divide by 2. So that way x is negative 1. If your x is negative 1, your y is positive 1.
1, 1.
Negative 1, 1 is your solution.